Here we'll look at scientific notation. So the idea of scientific notation is we have some number a times 10 to some exponent. And in particular, this number here should be less than or equal to 1, or greater than or equal to 1 and less than 10. So the idea of scientific notation is when we have these really, really, really big numbers or really, really, really small numbers, in particular with lots of zeros. And they can become difficult to count, so we use those as exponents of 10. For example, the mass of a proton is very small. These things are super, super tiny. And we write this as 1.67 times 10 to the negative 27 kilograms. You can also look at really big numbers, like the mass of the planet Earth, which is 5.98 times 10 to the 24 kilograms. So these are examples of numbers in scientific notation. So let's look at how to do this. Well, the first step is to count the number of places. The decimal point should be moved. So remember, when we're doing this, we're looking for a number between 1 and 10. So when we say how many times the decimal point should be moved, we're looking at how many times it needs to be moved to make this a number between 1 and 10. Second step, kind of the third, is if the original number was greater than 1. Then our exponent will be positive. If it was less than 1, so if the original number is between 1 and 0, and 1, the exponent is negative. And this number for the exponent comes from how many times we move that decimal place. So let's do some examples. Here we have this really big number first. Since there's no decimal place in the number, we know it's at the end. If we want to make this between 1 and 10, we have to start moving the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So we have 9.48 times 10. Since our original number was bigger than 1, this is to the 9th power. On our second example, we see our decimal place. If we want to make this a number between 1 and 10, we start moving it to the right. 1, 2, 3, 4, 5, 6. So now it's 3.95. Since our original number was between 0 and 1, our exponent will be negative. We can also do this for numbers that aren't overly large or small. For example, here, we would only need to move the decimal place once to get 2.89. Since our original number was bigger than 1, it's just 10 to the first. When we're dealing with an exponent of 1, we often won't even write it. We can also write this as just 2.89 times 10. For the second one, we would have to move the decimal place twice. Since our original number was less than 1, we have a negative exponent. Let's now look at going the other way. 4.91 times 10 to the 11th. So the fact that we have a positive number as our exponent tells us that this number should definitely be bigger than 1, and we should be moving the decimal 11 times. So here we'll move it once, twice, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we can put commas in. And you can double check and count these. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, plus the 1 and the 9 gives us 11 total spots. Our second example has a negative exponent, which tells us this number is going to be less than 1. And we need to move the decimal 6 times. So we have 1, 2, 3, 4, 5, 6 times. So 5 zeros and then the 384. A couple more. A positive exponent of 4 says this number is bigger than 1. So we would move the decimal 1, 2, 3, 4 times. The last example has a negative exponent, so our number is less than 1. So we would move the decimal 1, 2, 3 times, 0.0061.